so far?
Sorry.
As you know, this webinar is going to be recorded, and Josh will be posting this link after the event, just so you know. It may or may not pop a window up at you. So welcome to Cloud Native San Francisco, where all things cloud native are talked about: containers, service meshes, microservices, everything in between and beyond that. Please join the meetup if you're interested in topics like what we're covering today. All are welcome. Josh, who you all know, who organizes this event, will be providing the meetup link in the chat window. I'm Melinda, and I will be your host for Adam's talk today. I work at a place called Eggy, where our team is working on making internet-scale event-driven distributed systems accessible to everyone. And before that, I worked at Visco, where I met Adam, where we chose Mux, which we'll hear a lot about today, to transcode and stream video created with Visco to our social network of tens of millions of users. So for those of you just joining, our speaker today is Adam Brown. He's been developing software and architecture for audio and video for over 10 years. Starting in 2013, he built live video encoding infrastructure and low latency live streaming at Zencoder, which was then acquired by Brightcove. Then he spent a few years building cloud VR rendering at Otoy, after which he missed cloud video so much he did it one more time as a co-founder and head of technology and architecture at Mux, where he is now. Mux has really changed the game for video streaming on the internet and become a billion-dollar company in the process. Video by bytes put through is by far the biggest part of the internet today. And Adam will teach us today all about how Mux built and evolved this critical infrastructure using Kubernetes, Envoy, Prometheus, Bazel, Kafka, and other cloud-native open source technology, and how Mux has really managed to stay at the leading edge of technology while serving its existing and new customer base. So just some logistics. If you have questions for Adam during the talk, he will be taking them through the talk, so please feel free to post them in the chat. I'll be doing my best to get them to Adam as we go. And for any questions that we don't have time for during the talk, we'll queue them up for Adam, and we'll wrap up with full Q&A. And I know that some of Adam's coworkers might be in the chat, so we might get some bonus answers on some other sides of this story. And with that, I will shut up and hand it over to Adam.
Awesome. Thank you, Melinda, and thanks, Josh, for having me here. I'm really excited to talk through what we've been working on. Let me see if I can get my screen sharing back going. And hopefully you can see that okay.
Yep, I can see it.
Getting closer, getting closer. There we go. Okay, so yeah, thanks for the great intro, Melinda. So like she said, I've been basically working on processing media in the cloud for my entire career at this point. So live video at Brightcove, cloud VR rendering in Otoy, and most recently and currently video again at Mux. Let's get back on here. So kind of the premise of this discussion when Josh reached out several months ago was, we talked about how at Mux we're running Kubernetes ourselves, and maybe answer a question like, should you go down this path as well? I'm not going to answer that question probably for you today. It's a really complicated path to get to. I think in most cases the answer is probably no. But I want to talk to you a little bit about like the decisions that led us here, and why we ultimately are running Kubernetes ourselves, and I mean that managing the master nodes ourselves in many cases. So to kick off a little bit of agenda, we'll talk about our products and why the footprint of our product is really part of what drives these infrastructure concerns. So the scale of video, the complexity of video really has everything to do with why we ended up managing so many services ourselves. Talk a little bit about that in detail around our infrastructure itself, as well as our experience with managing Kubernetes, and finally some of the tooling that we've used that's open source, and some of the stuff that we've built in-house as well. So at a high level, what Mux does is we build video tools for developers. So we try to solve the hardest problems that developers face when building video. So streaming, observability, and more. So delivery and coding, all of these things are wrapped up in our product. Two products today, Mux Data and Mux Video. Mux Data came first. It was the first product that we developed at the start of 2016. And that product monitors video playback performance in real time. So basically we build client SDKs, so an SDK that hooks into your JavaScript video player or your Android video player or iOS. And today we've got a large number of these SDKs for even things like Roku's and Tizen TVs and stuff like that, that measure kind of the performance of the video playback on the end user device. So you can answer questions like, does iOS have worse startup time than Android? Does my video perform better in Comcast or Verizon or in the US or Canada? And ultimately, answer, why are you getting these support calls? This product is really important for people operating video platform teams, are people operating video platforms, including ourselves. So we operate as our other product, our own video platform, that's Mux Video. So it's an API to video, both live and on demand, from source to playback. So it's kind of this headless API approach that is very developer friendly, thinking docs, support, and compatibility first. We've got a few kind of unique ways that we do things, which is the scope of another talk, in just-in-time encoding and live. Live became really, really important for us, and a critical part of our business, especially last year during the pandemic. We were fortunate to be able to power a lot of really compelling use cases and interesting new use cases that popped up, and those are kind of continuing to grow and be important for us. So talking quickly about the first product, this is a screenshot of our real-time dashboard. We believe that data is one of the secrets to great video. If you look at where you expect video playback to work really well today, YouTube and Netflix work really reliably most of the time, and they have invested heavily in this data infrastructure end to end. One of the core kind of philosophies of this is that we want to make the data actionable, and ultimately improve the viewer experience, and automate content processing and delivery to any device. So this dashboard on the right, there's a very large American football event every year that we can only refer to as the big game, that we've actually been the analytics provider for the past 3 years. And this view on the right is our real-time dashboard, which is kind of the war room view. Think like the Grafana dashboard for video playback. So it's something that we're really proud of, and kind of some expectations of the scale that we're working at here on the data product. On the other side of the company, the video product, this picture here is what Amazon gives you when they say how to build video on their platform, on AWS. So as you can see, there's a lot of AWS services included here. There's a lot of complexity to building these workflows. We really think about these in kind of 6 core components: storage, ingest, transcoding, monitoring, distribution, and the whole workflow component. So how do you know when a video is done processing and tie it into your own app? This is a lot of complexity. This is it takes dedicated engineers to build this, and the Mux approach is to put all of that into one video workflow behind one API. So you give us a video file, a direct upload. We pull it from cloud storage, or the common use case of pushing us a live stream. We give you a playback URL where all of that complexity is encapsulated in the middle. So HLS, delivery with multi-bit rate encoding, that just works on any device, and we can enhance a lot of our decision making behind that with our data product as well. So the complexity of this product, you can kind of see everything that we're wrapping up there. It leads to a lot of product concerns around our infrastructure. Most importantly, video is really, really resource intensive, and you can that analog to that is it's very expensive, right? So video uses a lot of compute, storage, and networking. Compute for transcoding, storage, and networking for saving off the videos or distributing it out. And this is such a a complex and expensive operation that companies like YouTube are designing their own video hardware to solve this use case, and other companies like Twitch. So these like YouTube and Twitch, very large user generated content platforms, they both have their own dedicated hardware, dedicated data centers, and we're not directly competing with them. We're allowing other people to build similar platforms, but we need things to be really cost effective as well, and we're starting out on public clouds. This is really kind of core to the rest of our decision making here. Is how do we have flexibility to take control of our costs in the long term, and as we'll talk about in a minute, what kind of drives us to wanting to be portable across multiple clouds. So the other piece of this is reliability is really critical. On the data product, obviously, collecting all of the data is very important. Not having gaps in the data, and especially at these very high volumes, like a very large sporting event with millions and millions of concurrent viewers. Video playback reliability is kind of our pinnacle goal objective. This is why people are coming to us, because we're saying that we can do this better, especially for live events, right? Like live events have a people aren't going to wait for a broken live stream to start working. They're not going to pause a large sporting event for some cloud infrastructure company to get their act together. There's a lot of money tied to these events, and provider redundancy has almost become table stakes in like the video streaming industry here. One example of that is not only were we like looking at running on multiple clouds, but multi-CDN is really kind of a very common use case for any moderate to large video provider. This is just a little example of how we had, this is a blog post on our blog you can go check out, where we routed around a large network outage from a few years ago. You're probably all very familiar with the Fastly outage a few weeks ago that we were able to, we weren't totally unscathed by that. We were able to work around it quicker than they were by shifting to some other CDNs. But it just goes to show how important this kind of multi-provider strategy is. So switching to talk about what our infrastructure looks like today. I'm going to go through each one of these bullet points in a little more detail in a second, but we are multi-cloud running on AWS and GCP. Everything is deployed with microservices running in Docker containers, and there's mostly Golang, gRPC, some Elixir services as well. Everything we deploy runs in Kubernetes. We have minimal reliance on managed services. So we do still use a few that we'll talk about. We self-manage Kubernetes in most cases. And we use a very large collection of cloud native tools, including a few new tools that we've built ourselves. So at a very, very high level, this is kind of what our multi-region architecture looks like. You can think of each one of these boxes here as being a cloud region, and these kind of CDN edge in front of them. You can see a lot of redundancy built in here. There's complexity too. So CDNs talking to each other, failure paths, where if the CDN, say for example, in this case, if Fastly were to fail, Cloudflare could go directly to our origin, and then multiple paths into each region itself. A lot of this is tied together. I wanted to put a little cockroach DB thing down here. Like we've relied a lot on cockroach DB for some of our backbone of our data plane here, as well as orchestrating each one of these regions with its own Kubernetes cluster. Won't really go into too much detail. This is kind of a zoomed in view of one of our video regions, how our just kind of highlighting our microservices, kind of event-driven architecture with Kafka and our kind of custom microservices behind here. But this is a little more detailed than I think we're looking for in this talk. So I'm going to pull up and talk about our multi-cloud strategy at a very high level. For us, it's really more about portability than it is about cloud features. I think, I in preparation for this, I was looking up, why do people choose multi-cloud? Like, what are the talking points there? And one of the top ones is to be able to kind of get the, use the cloud features from the best that fits your need from each cloud provider. That's not really a big driver for us. It's more about cost than anything else, because those workload costs can vary greatly between clouds. Just things like network egress from, you can look at Amazon or Google standard egress pricing. Those Those are different. They're different depending on who those networks are pairing with, how we're egressing it, say if it's going to Fastly or Cloudflare or whoever. Those costs could vary a lot, and these costs are very significant for when you're delivering video at the scale that we are. Also, consistent infrastructure is really important to us. Consistency is a theme that you'll see over and over as we go through this. You can get into a lot of complexity operating between, when you're trying to operate against different cloud providers, APIs, and things like that. So really, you're building against, in this case, if you want portability, the lowest common denominator of the cloud provider. So even if one provider's managed service is fantastic, if you want portability, you can't rely on that on the other. I mentioned earlier, live streams don't really care about your monthly SLA. They care about what's happening when the live stream's going on. So having that flexibility to say, well, the cloud provider A is down, can we move to cloud provider B and as quickly as possible is really important. And finally, I think that, and building out as a startup, starting from scratch, building out all of this multi-cloud stuff, it wasn't the multi-cloud thing that was the hard part. It's distributed applications in general. Being able to go from say running in one region, whether it's multi-cloud or not, to two regions is really where we've spent most of our engineering effort. So on our microservices side of things, like I said, we're running everything in Docker. That seemed like the obvious choice. Even in 2015, when we were starting, everything was moving there. Everything's in Kubernetes today. We didn't start there in 2015. Kubernetes felt a little bit new. We were just trying to get something off the ground, and in that early prototype stage, the very first thing we used was Rancher, their original managed project. That got us a pretty long way with some of our original products before. When we built video 2 years into it, we actually built that on Kubernetes and in learning Kubernetes really well, migrated all of the old Rancher stuff onto that. So today everything's built in Kubernetes. Golang and gRPC protobuf kind of is kind of the application ecosystem for our microservices. It's all multi-region distributed applications powered by this CockroachDB data plane with Kafka and Consul replicating some data across these regions as well. So yeah, I mentioned earlier, we didn't start on Kubernetes, but we got there pretty quickly. We did our databases all in containers. I said before it was cool. Back when we were starting, I was originally like deploying Postgres ourselves. Starting to run Cockroach there, and people weren't really doing that yet. There was a lot of hesitation. We got really good at running databases since day one. Our very first deployment at the end of 2015 had our Postgres servers running in Rancher at that point, but then Kubernetes. We've had to build a lot of internal tooling and systems. We've been through several iterations of our YAML pipelines. We've used Helm and we've used but really we found the need to customize things more than a lot of those toolings that existed allowed us. And so we've been through a couple of iterations of our internal tooling that I'll talk about a little bit later. But ultimately, what we've really been happy with Kubernetes is we do have that consistency from dev to staging to production. We use things like K3D now in developer environments that the YAML files look very similar as they move through the system. So on the topic of managed services in general, we do still use them. We do use some managed services for Kubernetes in non-production workloads. So for things like data warehousing, machine learning workloads where you just want that like one click, let's get off the ground running. Whenever it's not a performance critical piece of kind of SLA'd infrastructure, where we're happy to use those kind of managed services. We use a few like database providers, like RDS, for example, and a few instances as well. We're really good at finding the performance edges of these managed services, though. We relied on our data product very early on Kinesis. That got us a really, really long way, actually up into the very first big game that we ran. But before that, we realized Kinesis had some limitations, not just around workflows, but also kind of scaling challenges. And we moved to running Kafka internally. Similarly with Redis, we've used a lot of external Redis services. Find the edges of that, move it inside. Same with Postgres, moving to CockroachDB, which we run ourselves. So I bring that up to say, the kind of context of this talk is about managing Kubernetes. We've in general moved from managed services to running it in-house ourselves, across the board with all services, not just Kubernetes. So let's talk about that, managing Kubernetes. So the pros to self-managed Kubernetes that we found in practice is really actionability is number one. We're not dependent on opening a ticket with a cloud provider when something goes wrong. We can get in there and fix it. This has been flexed many times. We've had a lot of cases where some kind of critical performance bug, that we would have had to wait for a response on the ticket, but we had the ability and the capability internally to fix that quickly. Also, visibility into things like how the master nodes are running. It has been, I wouldn't say it's been as important, but it's certainly been very useful. Also, we do have to do things like scale the nodes ourselves. That really hasn't been that big of a burden for us. Control. If we never have to ask ourselves, is it possible to do this? Is there some host image limitation that won't allow us to do what we want to do? We always know that we can work around the technical challenges if we need to. I mentioned consistency a few times, and how important that is. And in this case, consistency across cloud providers. This has been a bit of a up and down stories I'll talk about a little bit more in a second. But being able to have kind of as similar as possible configurations across multiple cloud providers, and being able to start thinking about, well, what if we ran this on bare metal? What if we did need our own data centers one day? Today, we're in a place where that feels very consistent. Finally, portability. Put potentially here, because if this is a potentially a pro, if you go all in and you're not using any of those other managed services, you can get really good portability. So today, with us using Cockroach, it's very easy as our database backend. We can move this between cloud providers really easily. The big cons of self-managing are obvious, right? It takes internal resources and expertise. It does take time away from the team. We were fortunate early on to get some really expert folks on the team that had worked on Kubernetes internals in the past, worked at some of the big cloud providers in the past, and really had this expertise on this team. Without this would not be viable, I think. Along those same lines, the toil here is kind of hard to quantify. There's two ways to look at it. In one case, it's really easy to say this is a huge win when the cloud provider's down and we can work around this issue on our own. But then there's also those a million little cuts of, well, now we have to tweak this thing and that thing. It's been, anecdotally, it seems like it's worth it. I would say though, overall, this is the really difficult thing about self-managing it. It just, there's always something else to tweak. There's always something to fix, and without kind of really really seeing the value of it, I think it's hard to justify. So speaking of those reliability and actionability points, if you look at, I was going to pull up actual cloud provider outage dashboards. I'm not going to do that, but if you look at the outages there, you'll see that the managed K8s provider, the services outage numbers are much greater than the underlying infrastructure outage numbers. We've had a number of times where we've wiped the sweat from our brow, saying, "Well, sure, I'm glad we're not on this cloud provider infrastructure right now, or on this managed service right now, because it's having problems." The master nodes do require some maintenance, but less than I think that we expected. This has been surprisingly rock solid for us, just kind of deploying those out. And finally, we've been able to fix bugs on our own schedule. I put this little screenshot down here from a Linux kernel bug that was affecting all of one cloud provider's infrastructure, and that we ran into ourselves in our own in our own stack. It was actually causing a kernel panic. It was only affecting people with very high volume of networking like ourselves, but it was straight kernel panicking our entire stack on a regular basis. And we actually were able to, because we managed it ourselves, we're able to kind of get our own kernel build out and work around this. It took months for the cloud provider to fix this because not all use cases, we were seeing it more than others. So thinking about like the evolution of managed services in Kubernetes and kind of over the timeline of our company, we started in 2016. It really felt like the managed services were very limiting and kind of unreliable. We were hearing horror stories from other companies about how they were having trouble. And this pushed us down the path of, well, maybe we run this ourselves. We know where we want to go. We want Kubernetes. It seems like the right tool for us. It seems like the ecosystem's going that way. And then in 2018, it feels like the wind shifted a little bit. Open source tooling felt clunky and it was lagging behind. The managed services really caught up. We were like scratching our head a little bit, like did we make the wrong choices? But I think by 2020, the tooling has really matured. And the open source things, which I'll dig into a little bit more in our tooling in a second, really feel on par with a lot of what the cloud providers are offering. So yeah, speaking of tooling, we use a lot of open source stuff and we run almost all of this stuff ourselves. So Prometheus and Thanos for metrics, Envoy for internal gRPC load balancing and routing, Jaeger for tracing, Elk Stack, we run all ourselves, manage the Elasticsearch clusters. Bazel is our new-ish build system that's kind of tying this all this together. And finally, two things that we built in-house, Styri and Virgo. So Styri is our templating language based on Starlark. It's really much more than templating. It's a full DSL for our configuration. And Virgo is the name of our kind of wrapper around our wrapper around the cluster API today and the provisioning a lot of the components. So see a question around cops in the chat, which I'll get to in just a second. So Styri is the Starlark DSL, like I mentioned. It replaced another in-house tool that we had in-house that was built in Golang that was really just a YAML kind of templating tool. It's really well integrated and complements Bazel well with Starlark. We use like Starlark Go for type checking as our proto definitions. Gives us a lot of confidence during kind of the build and rollout phase that there's not mistakes made with some of these configurations, particularly when we're generating like Envoy configs here, because Envoy takes the proto definitions that are ultimately output from this. Virgo is probably the more interesting kind of wrapper around all of this stuff. Virgo encapsulates the cluster API. Cluster API, if you're not familiar, is kind of the abstraction that allows this tool chain to say spin up Google Cloud versus Microsoft versus AWS, and it adds a layer of abstraction to that. Before that, we used COPS, and that's where we did see some challenges with managing things like upgrades and just when I was referring to the tooling felt a little immature. COPS there didn't really fit that full need that I think the managed services were providing. But now with this cluster API, it allows for kind of almost perfect portability between clouds. I asked one of our platform engineers the other day, what is the difference between, today our configurations for like Google and Amazon is like, there's like 5 lines of code different in our Virgo configs, which is a really nice place to be. Also, a number of like cluster upgrades are just handled very cleanly by these cluster APIs. So that's really it as far as tooling. I'm happy to dig in to any of this as much as possible. But kind of in conclusion, the stage and the expectations of your project are really everything if you're considering running and managing Kubernetes yourselves. Step one, do you really want to even go Kubernetes at all? I think we see a lot of people that are building on Mux today. We're using our video API, building on some of the Lambda type use cases, the the codeless serverless platforms. I think those are really powerful for most projects getting started. But once you reach a certain complexity and you want to go to Kubernetes, if you're thinking about running it yourself, self-managing is very much not free. There's a question in the chat around did we decide to self-manage it ourselves because we had expertise, or did we decide to do it and then hired a team to do it? It is more the former. We had that expertise on the team, people who were comfortable doing this already in the past, people who had worked on some of those core components of Kubernetes and their kind of analogous system at cloud providers, and so that drove a lot of our confidence that we could do it. At the time that we were kind of deciding to do this, we definitely weren't. We were in the mode of building a product to stream video. We weren't in the mode of do we want to like challenge ourselves by running Kubernetes ourselves? I think we always knew we would get here. There's dreams of and realistic vision, I think, of needing to have more control over even the hardware longer term to keep up with what some of the other players are doing here. Finally, if you're interested in video engineering, we run a conference as well called DMUX. It'll be in October. It's growing really quickly, but all of this, we talk about video compression, distribution, and all of these kind of infrastructure problems as well. And if you're really, really interested in video problems, then we are hiring. So we're definitely have things to work on across the whole stack: Kubernetes, video, and data. So please reach out if you have any questions or are interested in a job. That's it.
Sweet. Wow. Thank you so much for that, Adam. It's rare to get a nuanced take on the real trade-offs of managed software that isn't from a vendor that's trying to sell you on one side or the other.
We're only trying to sell you on video. So.
We'll use the rest of the time for more Q&A. We had one more question already, and please, folks, feel free to drop any question that you have for Adam in the chat. Ups and downs of Oakland, pro or con video, anything like this. Shrivavan has a question in the Q&A here. Were performance SLAs a factor to go self-managed? You mentioned that some of your non-production facing services that don't have SLAs can remain managed. Can you tell us a little bit more about that?
Yeah, I think it's not in the baseline, not baseline performance. You with many of the cloud providers, you can roll your own nodes there and kind of have a lot of control. It's really more about that those the flexibility at any time to be able to route around an outage. So like the cloud provider, the full cloud provider outage or the regional outage, more than it is like a specific. So that is an SLA in some sense, but more about uptime than it is about performance. If that's what you're asking.
Got it. I have a question for you. Do you feel like you talked a little bit about the need to have these highly specialized experts in order to self-manage, and you talked about a pretty wide array of open source software. Do you feel like the need to have highly specialized experts is mostly important in the beginning, or is this an ongoing thing where you need to maintain experts in all these areas across the whole stack?
Yeah, I think it's. I think at the time it felt more important than maybe it does now. Like I said, the tooling has really reached a much more mature place. I think we've been. I think I've been a little surprised by the problems that we run into with some of these self-managed things. And this doesn't necessarily just. This is not specific to Kubernetes. It's all of these tools. If you had asked me when we were first rolling out Kubernetes and said, oh gosh, are we going to run this ourselves? Like I would have been sure that we were going to be fighting Kubernetes master nodes uptime for the next, indefinitely. We've had some things there, but by and large, like that has not been the issue at all. And even the same way for things like, like Elasticsearch or any of the other kind of things that you manage yourself. It's not like turning them up and keeping the containers running is not the problem. It's all the tunings that happen as you scale, and that's where the expertise is really really valuable. So a lot of this expertise is not specific to these tools. It's like it's having that kind of SRE, like, you know, deep, like, kernel knowledge mindset that makes it. I was preparing for this, and talking to one of our like very senior folks on this. Is like, you know, we it's hard for us to quantify, you know, how much time we spend here, or if it's the right decision or it's not, because, you know, we happen to have some of this, you know, deep expertise on like kernel level stuff that comes with a lot of video engineering, because you are moving so much volume and you're pushing machines to the limits, that we you know, oh, it's a kernel bug, we'll just be like, you know, patch that up and fix it and move on. It's very second nature to some degree. And, you know, so I don't know, to answer your question, I don't think that it's required to have this deep level of expertise to run this stuff. I think it's when you start scaling it aggressively and finding the edges where it you know, where it really becomes powerful and necessary.
Got it. You said that it was surprising that keeping the master nodes up was not the problem. Yeah,
that's right. Yeah, keeping the master nodes running has never so far has not been any trouble for us, really. It's you know, there's been cases where we've made mistakes, like, you know, that we wouldn't have had like certificates expiring, things like that, right? And had like gaps in metrics. But, you know, for the most part, it's like, okay, well, this master node is reaching a CPU limit, scale it up. And that is an action that needs to be taken. But that being said, that is a relatively quick and simple fix. You just don't want to have, you know, you don't want to have that all day, every day. And in reality, I don't think we've really run into that.
Got it. And Sanjeev had a question elaborating on that. When your team is making these, say, kernel level tweaks, how do you think about contributing back to the open source ecosystem? Does Mux participate in this heavily? For example, tweaking the kernel to fit your use case?
Yeah, absolutely. I mean, I think, like, you know, some of the kernel tweaks, you know, I think that was more like working around bugs with a different patch. So it's like somebody else was fixing that. But we definitely make a lot of contributions here, especially around some of these tools. You know, find a bug here or there. There's where we very much encourage these you know, contributions back. We do it whenever we run into them. I know we've made quite a few Kafka tweaks that we've pushed back, particularly around performance, and one of the larger ones is around how some of the consumer groups work there to fit some of our specific use cases. So yeah, it's highly encouraged. You know, we just don't really like running into them to begin with.
And how about Steri and Virgo? They look like really useful tools with pretty general applicability. And, you know, Mux does run this fairly robust open source program. Have you considered open sourcing them? Yeah,
it's a thought. They're in that kind of early stage where they're, you know, highly customized to us. They are, you know, it would have to become a project to open source those. I think as we iterate on them a little more, very, very much may. Yeah, it's something that we honestly haven't talked a lot about yet, just because they are so early. Like those didn't exist at the beginning of 2020. So as we iron out the bugs and find the places to abstract them for more community engagement, I imagine we'll contribute them back.
Got it. I'm trying to figure out the internal naming scheme that these are indicators of. Yeah. You've mentioned a few times that the toil is hard to quantify. Can you talk a little bit about at all about the size of your teams that manage this, or are they so ingrained into the rest of your team, your future teams, that you really can't say?
Yeah, so our teams, we've grown a lot over the past 2 years. We're right around 100 employees now. And I think at the beginning of last year, we were right around 30. And so for a long time, we were the engineering team was kind of one big team that had a handful of people. Say when we were started, we had maybe 4 people that were really kind of dedicated to the platform side of things, and four might be generous because they're also working on product things as well. Today, we do have a platform team that's more or less focused on this. I think there's 5 or so on that team today. Maybe we added another one. I know we've hired a lot recently, and this is a place where we're in particularly trying to hire. So if this is where your expertise lies, please find that jobs page. But yeah, it hasn't taken a huge team. It's just taken a lot of that team's time on the toil side. And I also mentioned, like, we're not we treat the Kubernetes clusters a little bit. We don't have to solve a lot of the harder problems that, say, like larger companies do when you're thinking about multi-tenancy and things like that. Like we're much more of a deploy many small Kubernetes clusters that are like really just kind of application orchestration engines that are independent, and that lessens the burden of some of the Kubernetes scope that you can get into when you are solving those kind of large scale deployments, which is someone in chat mentioned, is it suitable for large scale deployments? I mean, it depends on what you mean by scale. Like we run a lot of nodes, in some of these clusters, but a lot of those nodes are doing the exact same thing. So like I said, we don't have a lot of like namespaces, not a lot of users, not a lot of that, but there may be several hundred or 1,000 like transcoding nodes, right? So it depends. As far as like scaling for lots of nodes, it's been fine. We haven't had any issues there. Early on, I think some of the earlier Kubernetes versions had some trouble there with like etcd scaling, but I think we've, for the most part, haven't run into that recently.
Sanjeev has another question. Here, yeah. How do you, just for the recording, how do you handle the observability in these large systems?
Yeah. So I'll go back a couple slides. So on our tooling side, I think the metrics, like everything that we do is instrumented with Prometheus. Every container in some capacity is managed by Prometheus, and then those are bubbled up via Thanos to kind of centralized metrics and SLIs and SLOs, those kind of things. Centralized logging with elk stacks. Generally, the way that we think about it is each cluster has like its own detailed level metrics. So there's, depending on the use case, and in most cases for these very large regional deployments for video, like each cluster has its own elk stack. And Prometheus stack, and if you're looking for a problem there, you kind of go get this full view into that. But then that also exists at a higher level, like the global level metrics, where they're aggregated a little bit. But we've been really happy with the Prometheus stack for observability there, and also obviously Jaeger tracing. Tracing is not as often used as the others are, but when it's important, it's really important. So yeah, the tooling system here feels really surprisingly mature. I mean, it feels like everyone's using Prometheus today. So yeah, we feel like we have really good coverage there.
We have a question from Brendan, engineer at Stripe, previous of GitHub, Cisco, Pinterest, Facebook, and more. Sorry, Brendan. Which I'll read for the recording. Uptime and failure resilience seems to be incredibly important, both to Mux and to your business domain in particular. Are there any processes or frameworks that you could share that have worked at Mux's scale to ensure that you're able to quickly identify and remediate incidents across a large amount of self-hosted infrastructure and multiple clouds and regions?
Yeah, so it's interesting when you say at Mux's scale, because we're a relatively small engineering team, and I think a lot of these problems really are maybe come out of the when you have really large teams and stuff kind of flying all over the place. For the most part today, everyone's somewhat familiar with all of the services running on the engineering team. So on that side of things, there's not a lot yet. But what we have, we've invested heavily on the process side in our for example, these Prometheus metrics and things like that in our alert manager builds. This is part of the Stereo configs and things today, where every service has a very standardized set of metrics, automatically gets all these kind of standard alerts applied to it. Obviously we can bring in more, but the standards are what you'd find in the Google SRE book. Where every alert is tied to exactly what service triggered it. There's a run book attached to the alert if it happens. Pretty it's right to say robust kind of incident management practices today. So we use a system called blameless.io. They're great. Just check them out for managing this. It automatically spins up a Slack room when, in the case of an incident, gives all the context there, manages kind of the post-mortem process. And so that process is something that got it's had to evolve over time, but a really well-defined post-mortem process has been important to managing this, as well as kind of the templating infrastructure to ensure that no service can kind of sneak out there without proper tooling around it.
Thank you. Channing has a question. Do you extend your Kubernetes lowest common denominator abstractions to more specialty compute environments like edge compute with CDNs, and in your case, specialty video hardware? If not, what do you think is the inflection point of the platforming being too unique?
Yeah, this is a great question. So we don't use any specialty video hardware today. I think it's going to be really interesting here when we get to that. I think where that'll be mostly handled at the application layer, saying like, okay, this part of our application supports this, like route this traffic over there. We haven't really had to solve that problem yet today. Now on the CDN side, this does not apply at all. At least with the cloud providers, you can think about them as kind of core components of compute, networking, storage. You can do some balancing around, the costs are different and maybe there's slightly different performance applications. But like things like the cluster API have abstracted away a lot of the differences in interacting with them. CDN, so part of like why we're so interested in like abstracting these cluster API problems away and making those least common denominator type problems is because we spend so much time on managing the differences between CDNs. This is a part of our direct value add to customers of a video product, where we can say, you want to do video, as I mentioned earlier, you kind of have to be multi CDN to do it at any professional say level today, and the CDN intricacies are a mess. I think that we're trying to find places where we can do something like build some cluster API like consistency across them, but we're also at a place where we're adding new ones all the time, find that this one doesn't support A, B, or C, and this one does, and this is where this is kind of the core part of our business, I'd say, and where we have a lot of complexity that we unfortunately spend a lot of time on. Hopefully that gets better in the future, but today, those APIs are not even remotely similar.
Tribhuvan has a question also about frameworks. Have you done a very specific build versus buy analysis? And if so, what are your observations from the structure process?
Build versus buy, so for presumably for managed Kubernetes.
Yeah, for managed Kubernetes, or for managed, I guess, any of these other pieces.
Yeah, like I mentioned earlier, we're happy to entertain managed services, and it's particularly early on, and we've done it a lot. I think I had that slide up here somewhere. So for example, with Kinesis, we do that. We did that analysis earlier. Not too structured. I mean, obviously we're a startup just trying to focus on the product. We don't have at that point at least didn't have time for this major undertaking of analyzing every which way that running Kafka ourselves could go wrong. So we say, okay, do what any reasonable startup's going to do and choose the managed service that we think is going to work. Ultimately, we're finding more and more that we run into those performance problems at the edges. We're I'd say we're very quick to pull the trigger of moving to self-hosted when we start seeing those problems. We don't have a lot of tolerance for managed services that don't completely solve our problem. So it's kind of to answer your question is generally we've said, managed service first, and then very quickly move towards the self-managed.
Got it. And on the flip side of that, I guess also related to incidents, have you seen, as Brendan mentions, bugs where you find that what went wrong was in the self-management of the system? And if so, like what proportion of incidents are caused by something like that?
We've certainly been there. Like I mentioned earlier, I know we had an incident a while ago with like certificates expiring, right? Like between some master nodes or something like that. And I've triggered an OK Google here. So I'd say a low percentage of them of our incidents come from the self-managed process. We're more likely to make a mistake, honestly, at the CDN layer today with all of that complexity between different CDNs. Dealing with some of the complexities around collecting logs and data from CDNs has been a really challenging place for us as well. But no, I'd say by and large, with the exception of like the non-public facing incidents, like things like Elasticsearch disks filling up and things like that. So these like internal incidents happen more often, and that's where the toil comes from, right? But public product facing incidents, I'd say no, a very low percentage of them for us have been due to the managed versus unmanaged kind of split.
Nice. We have time for a couple more questions. If anybody wants to drop anything in the chat, please go ahead before we lose Adam. You've talked about, you mentioned Envoy for internal routing. Mm-hmm. Could you talk a little bit about how you more about how you shift traffic across your regions and across your clouds?
Yeah, there's a. This is a talk in and of itself. To be honest, this is a whether we're talking about data or video, it varies. I also like ingest RTMP traffic, right, for live ingest. We actually don't use so we use a combination of cloud provider load balancers. This is one area where this gets a little bit more complex on that kind of least common denominator concept. We have this is another place where we've kind of slowly been moving away from the cloud provider services. Today, like for a long time, we relied on, say, like the load balancers from Google for our RTMP ingest. We've had to move away from that to managing ourselves because of issues, particularly for like RTMP is like a long running TCP connection. You could go 12 hours. Those load balancers do not play well in most cases with this use case. We've had to roll our own using Envoy and very specialized configs with this to say rotate them out gracefully and things like that. So we've slowly again are moving towards like our own infrastructure here. On the data side, interesting note on this, we are still using like Amazon's Elastic load balancers primarily, their classic version, because the way that the volume of this traffic works, we actually can't move to like NLBs or ALBs because of the cost model there, and we'll probably eventually need to do something ourselves there as well. So yeah, this whole networking area is kind of this is the place where we're making kind of the most iterations today and moving towards our own managed things and more control there. But again, we were happy to use them until we ran into the problems where they just don't fit our use case and or scale.
Sure. I imagine that just the sheer quantity of bytes that we're talking about is,
yeah. I mean, there's definitely companies doing much bigger. Like we're still tiny in comparison to the Netflixes of the world, but we're hoping to get there, and we're running into some very interesting challenges along the way. I definitely did not plan on spending as much time as I have like working through cloud provider networking intricacies. Probably should have, but should have expected it. But yeah, things don't always work as advertised.
And one last thing, you mentioned CockroachDB a few times, which makes it seem as though that is pivotal. Can you talk a little bit about data replication between regions or clouds?
Yeah. Cockroach has been a great kind of replacement for what we were traditionally, very experienced with Postgres, and Cockroach has been really nice for a kind of a drop-in replacement for that. And we use Cockroach in a few different ways for that kind of primary backbone of our video architecture. It's a relatively low volume use case that is replicated to multi-regions for everything. That one of the things we're working on right now is expanding kind of globally to more like European regions and thinking about things like GDPR and really expecting to rely on Cockroach to do like row level geolocation and in the EU and things like that. That's stuff we're working on right now.
Thank you for sharing.
Mm-hmm.
One last question, unless anybody has anything else. Ryan Quisenberry asks, curious how your team handles decision-making, driving adoption of new services, and aligning on when to migrate from an existing solution to a new and better solution, especially when you end up rolling your own.
Yeah, I think that answer's changed a little bit over time. Today, it would be much more driven by SLO misses, things like that. Historically, as we were kind of scaling quickly, it was more pain-driven development, I guess, right? Like, this thing's woken us, this managed service has fallen over, 4 nights in a row, waking us up is causing real customer risk. The decision process was more or less unanimous. Let's get rid of this thing. And in a lot of cases, I don't think we had, if we're in one cloud provider or another, and we were using like that cloud provider's managed service, we didn't have a lot of options other than either use that service that fits our needs or pull in the open source thing and manage it ourselves. Yeah, so I think that, as we've grown, that decision-making process has changed a lot. Today we're very much tracking, have great tracking on things like number of incidents caused by X, Y, or Z, and the SLOs impacted, and those kind of things, which are more the process today. But there's always that kind of when the person's been woken up, like I said, multiple times in a week for this one service. I think it's there's also those signals that get communicated to the team and again, I think our philosophy has been we're very open now. The more we run things ourselves, the better we get at it. We're more than welcoming of bringing stuff in-house.
Got it. Well, that sounds like a very nuanced take on that. If there aren't any more questions, I think it's time for us to thank Adam. Thank you, Adam, for
Sure thing.
Yeah, sharing such hard-won lessons. Again, don't forget to check out Mux for your video and data needs, and your platform needs, and do Mux. Josh, do you want to talk a little bit about the next meetup?
Yeah,
Thank you all so much. Yeah, for your time.
Yeah, thank you, Adam. That was fantastic. And here's our next one. It's actually going to be at 10 a.m. It's our first morning online event, so we'll see how that goes. But we have people from all over the world that have been joining lately. So we're going to have Rosemary, and then we're also going to have Jim, who's the ex-VP of DevOps at Goldman Sachs. He's actually currently doing a startup right now, but everybody knows Goldman Sachs, right? So that'll be next Wednesday at 10 a.m. Yeah, so that's it. Hey, Melinda, thank you so much for hosting this event. Really appreciate your support. And Adam, we would love to do an in-person meetup with you when you get into your new offices, hopefully in September.
Yeah, let's do it.
Awesome, guys. Thanks so much. Everybody have a good night, and we'll send out the recording as soon as possible. Thanks, everyone.
Thanks. Bye. Thank you.
Thank you.
Bye.